Okay, so in this section, we are going to learn how to graph and evaluate piecewise functions. This might be new to most of you. So what is a piecewise function? It's a function that's defined not by just one equation like you had in Sec 1, but it's going to be defined by two or more equations, and each equation is going to be valid for some interval. We call that a domain restriction. So over here on the right, we have an example of what the piecewise function will look like. The function is called f, and it's made up of two different parts, or two equations. So we've got a line when x is greater than 5, and another line that has a negative slope when x is less than or equal to 5. So they're going to give you the equation. Remember, x to the first means it's a linear shape. And the domain restriction when you're going to have that shape is always going to be given. And typically those x values are going to be the same. So your graph might meet up, it might not. You're not concerned with that. So how do we graph a piecewise function? The best way, I think, is to make a table for each part. So if we had 2x plus 1, I would make a table for that. And then the other part of the graph is negative 3x minus 4. So we would make a table of those values, and we would graph them on the same axes, okay? So when we get to evaluating, I'll come back to that. The graphing symbol, since we're graphing, this is a review from secondary 1. If you have the symbol on the domain restriction of less than or greater than, we indicate that by an open circle, which means we can go all the way up to that point, but we're not including it. If our domain restriction has an equal sign with it, we can include it, and so we show that with a closed circle. So let's go ahead and do an example. So in example 1, we have a piecewise function f, and it's made up of 3 parts. So you'll notice I have 3 tables. So on the first part of the graph, our function is going to be in the shape y equals negative 2x minus 4. And so we want to make a table of x and y values. To get the values on the graph, we do need to start with whatever the domain restriction starts at. So x is negative 1. We can include it because it has the bar, so I'm going to make a little note to myself that it's going to be a closed circle. And we need other values that are less than negative 1, so I'm going to use negative 2 and negative 3. To find the y value, we always substitute x into the equation to get y. So negative 2 times negative 1 minus 4 is negative 2. And now that ordered pair is on our graph. So let's go ahead and plot that. Negative 1, negative 2. And that's where we're going to start. Next, we'll substitute negative 2 into the equation. Negative 2 times negative 2 minus 4 gives us 0. So negative 2, 0 is also on our graph. And our third one, we know this is a line, so 2 points work, but I like to go to 3. So negative 3 times negative 2 minus 4 is 2. Oops, I said it, and then I didn't write it. There we go. So negative 3, 3, and then up 2. And so we're going to keep going in that pattern. So I'm going to start here, and we keep going, and we show that with an arrow. So this is part of our final graph. All right, next, we're going to do the middle part. So it's really like we're graphing the equation y equals, and it's negative 2. So this one does not have a variable, and that's okay. It's a good review. So our domain restriction, we want to start at negative 1, and we want to end at 2. And I'm going to pick a couple of points in the middle. So when I go to substitute those x values in to get y, well, there's nowhere to substitute, and so this is a constant function. What this equation really means is that our y value is always negative 2. So it doesn't matter what the x value was, okay? So let's talk about our starting and stopping circles. So we're going to start at negative 1, and we're not including that, so I need to make a note that that's an open circle. And then we're going to end when x equals 2, and that also is not included, so that's an open circle. So let's plot that. We've got negative 1 down 2. Now there's already a dot there, so I'm not even going to notice that that's open because it's getting filled in already. That's okay. Then I've got 0, -2, 1, -2, and my other endpoint is open. And it's all the x values in between. So we connect those, okay? All right, our last part of the graph is y equals x minus 2. And this is x is greater than 2, and we want to keep going. So I'll just pick a couple more. We are including that, so we're going to have a closed circle. And we're going to substitute to find the y value. 2 minus 2, 3 minus 2, 4 minus 2, and we're going to keep going. So 2, 0, and it's closed. 3, 1, 4, 2, and we're going to keep going. So follow that pattern. So notice, part of my graph did connect, and my other part did not. So it is what it is. If you were matching a graph, you could do the same idea. You would make a table and see which points matched up. All right, instead of graphing, what we can do is we can just evaluate a piecewise function. So when we evaluate a piecewise function, we're going to substitute the given x value, and we're using function notation, so it's like f of x. The value inside is the x value that they're requesting. And you need to look at the restricted domain to see which equation or part of the piecewise function you want to use. So let's look at example 2. So we've got this piecewise function, and it says evaluate for f of 1. So remember, this is my x value. So it's saying, hey, if x equals 1, what is the y value? So I look at this domain restriction first. This is how we're going to tell. So if x is less than or equal to 1, I use my top equation. And if x is greater than 1, we use the bottom equation. So we know x is equal to 1, which fits in the top restriction. So that means we're going to use negative x squared plus 1. And we're substituting 1. So you do have to be careful of order of operations. When we substitute 1, we do exponents first. So 1 squared is 1, times a negative makes this -1, plus 1, which gives us 0. Okay? And so we're also reviewing how to substitute values, order of operations to simplify. Okay, let's look at the second part. It says evaluate f of 4. So this is saying, hey, if x equals 4, which function should we use? Well, 4 is greater than 1, so we want to use this equation, x minus 1 quantity squared. And we know x is 4. So 4 minus 1 is 3. 3 squared gives us 9. Okay? So you don't want to use both parts. Only one of them should be valid. All right, let's try a couple more. So this one has 4 parts, and we have 4 restrictions. So it says evaluate f of 3. So x equals 3. So which of these restrictions is valid for x equals 3? Perfect. It's this one, because x is greater than or equal to 3. So we want to use 4 minus x. And x is 3, so 4 minus 3 is 1. Let's try the second one. F of -3. So x is -3. Which of these restrictions applies? Perfect. So if x is less than 0, that's when x is -3. So we want to use this equation, which remember, if we don't have a variable, that means our y value is always 0 for these x values. So it's 0. And our last one, f of 7. So find which restriction applies. Yep, 7 is greater than or equal to 3, so we're going to use 4 minus x again. So 4 minus 7 is -3, okay? All right, so on your practice, I also have some where the graph is given and you're evaluating the piecewise function, okay? And so keep in mind, these are x values, and you're going to find the point that is graphed on the graph, okay? But your answer is the y value. So when x equals -1, I'm really looking for what point is on my graph. So I go to -1, and we're going to match up right there. And so that y value is +1. And so this point, -1, 1, is on our graph. And so the y value is our answer. The next one, f of x, x is 1. And so I want to know what y value is on our graph. So we go to our graph. Here's x equals 1. And we kind of have two parts. But remember, the open circle doesn't count. That's just a boundary. We answer with the filled-in dot because that's included. So the point 1, 1 is on our graph, and so the y value is our answer. And the last example, when x is 2, we go to our graph, and same thing, we have two parts. The open circle we don't look at. We want this one, which has a y value of 3. So that's our answer. All right, and then the next one, this might be a little bit harder. When I give you the graphs and I give you the function, you have to match them up. So if you really know what your shapes are, you could probably do this a little quicker, but otherwise you really do need to kind of go through the process of making your table for each part and seeing which graph has that on it. So my first is going to be y equals x squared. And my second one is y equals 2. And so we've got, this is for x is less than -1. So I start at -1. It's going to be an open circle. And I want to be smaller than -1. So -2, and let's try -3. So remember, when you square it, you really do need to use parentheses if you're typing these into calculators, okay? It does make a difference. So -1 squared is +1, -2 squared is 4, and -3 squared is 9. So I want to see which graph has that. So -1, 1, that one doesn't. So I definitely know it's not C. -1, 1 has an open circle, yep. -2, 4, yep. So -1, 1. This could be open, we don't know because it got filled in. And then let's look at D. -1, 1, yep. -2, 4, no. So I definitely know it's not C or D. So we're looking at A or B. So on my second part, we know x is greater than -1, and this is going to be a closed circle. So I'll pick a couple more, and y is always 2. So I've got -1 up 2. This one's -1 up 2, no. So we know it's A, okay?